creating partial fractions in questions where we have a perfect cube denominator using algebraic long division method. So this video requires that you understand algebraic long division, so it's best if you go back and watch a video on that before watching this one. So this question, we have a quadratic being divided by a cubic. Now in this case, if we wrote it like this, where rather than having the cubed we have x plus 2, x plus 2, x plus 2, all multiplied together. This makes me think maybe x plus 2 is a factor of this quadratic and I can remove it, making the question easier. So the first thing I would do is look at this quadratic and think, can I factorize it? Now obviously there is only one x squared, so we have to have just x's. Now to get the 7, since it's prime, the only whole numbers is 1 and 7. And since all these signs are positive, these signs would have to be positive. But if we check this, this would give us 8x in the middle. So this doesn't factorize. But what that means is we can use algebraic long division to remove x plus 2 as a factor. So that would go like this. Obviously dividing by just x plus 2, not by x plus 2 all cubed. I'll explain why later. For now we just do this division. So to get x squared, we'd have to multiply this by x. So when we multiply all of this by x, we get x squared plus 2x. We're going to subtract all of that from our original quadratic, leaving us with no x cubed. Subtracting 2x from 5x leaves us with 3x. And nothing happens to the 7, so it just comes down. Now to get 3x, multiplying this, we would have to multiply it by 3. So that gives us, when we multiply by 3 through the whole thing, 3x plus 6. Subtracting all of this from our remainder of our quadratic gives us no x's and 1 left over. Now this is a remainder 1, just like if we were to try and divide 8 by 2, that gives us 4 exactly. But if we try to divide 9 by 2, that would give us 4 remainder 1, which this remainder still needs to be divided by 2. We couldn't divide it by the 2, so it is still divided by 2. So that would give us 4.5. So similar in this case, this 1 couldn't have x plus 2 eliminated as a factor. So x plus 2, x plus 2, x plus 2 are all still in this 1's denominator. So that gives us 1 over x plus 2 cubed. So this already looks like one of our partial fractions. We need to find the other two. So what this gives us is, because we've done this division, this x plus 3 did have the factor of x plus 2 in its denominator divided out. So the only thing left there is x plus 2 squared. Now this is now similar to a partial fraction question with a perfect square denominator, and so we can use the method for that to solve this part of the question, since this is already a partial fraction. So this would give us x plus 3 equals a x plus 2 b. Okay, skipping a few steps there obviously, but if you understand the partial fraction method at this point, that should make sense to you. So we need to eliminate a, so I picked the value of x as minus 2. So we get minus 2 plus 3 equals no lots of a plus b. So that gives us b equals 1. Now we found b, we need to find a. Let's pick a nice simple value for x. X is 1, so 1 plus 3 equals a times 1 plus 2 plus b, not forgetting that we plus the b, which we now know is 1. So that gives us 4 equals 3a plus 1. Move the 1 over, that gives us 3 over 3 equals a, which is 1 again. So now we've got that a, b and c are all 1, so our answers will be 1 over x plus 2 cubed plus 1 over x plus 2 squared plus 1 over x plus 2. That equals our original equation.